In order to add matrices, let's look at problem 3 part A and notice some patterns. We're going to go ahead and add this element of matrix A to this element of matrix B. We will add this element of matrix A to this element of matrix B. This one corresponds to this element in matrix B. And then finally, A22 corresponds to B22. So A plus B then becomes 4, 0, 5, and 2. And that is A plus B. In order to do A minus B, what's important here is to note with the order of these matrices. So A comes first, B comes second. I would suggest that we first write matrix A the way it is, then put a plus, and then switch all of the signs of all the elements in matrix B. So in other words, what we're saying is that we are going to use the fact that A minus B can be written as A plus negative B. And that's essentially what we're doing here. I'm taking matrix A the way it is, and then I'm adding a negative matrix B. This simplifies things so we don't have to wonder and worry about, oh, am I minusing a negative? Here, by setting it up like this, all we are doing is just adding. So this simplifies the process a lot. If we go ahead and pair elements from matrix A to matrix B and add, we get the following, which is equal to A minus B. Please note that B minus A would require us to write matrix B first by itself and then add the negative of matrix A. So the order does matter as far as A minus B is concerned and B minus A is concerned. If we consider these new matrices, matrix A and matrix B, you'll note that if we try to go ahead and pair things off, we run into problems pretty quickly. Who do I pair this with? And if you tell me to pair with this one, which is incorrect, then who do I pair this with? So you see, we run into some problems here. Now, note that you have matrix A has a dimension of a 1 by 3 matrix. It's one row with 3 columns. Note that matrix B has a 2 by 2 dimension. So these two matrices are incompatible for addition or subtraction because they have different dimensions. If, for example, matrix B was another 1 by 3, then we could go ahead and do addition on this. Or if matrix A were another 2 by 2 matrix, then we could do A plus B, as was done in example A and example B. However, we are given this situation, and we have two matrices with two different dimensions, and we cannot add or subtract that at all. So, because we don't have the same dimensions, and the elements don't pair off, we cannot add or subtract these two matrices at all in any direction. In order to be able to add them or subtract them, we must have the same dimensions. They don't have to be square matrices like I mentioned. So for example, if we have matrix A is a 1 by 2, right, with elements 2 and 1, and B is another 1 by 2 with elements negative 3 and 0, we could add these, right? So we can pair the 2 with the negative 3 and give us a negative 1. And then we could go ahead and pair the 1 with the 0, and that would give me 1. So I could add those two matrices together. And you'll know that when I add or subtract, they must have the same dimensions, and the answer also has the same dimension. So A was a 1 by 2 matrix, B was a 1 by 2 matrix, A plus B is going to be a 1 by 2 matrix as well. Okay? Here are some interesting matrices in part G. I want you to calculate A plus B, B plus A minus B, and B minus A. In this, I'm going to give you two matrices that are square matrices. Each of these is a 3 by 3. So you'll know the dimension is a 3 by 3 for A as well as for B. Always check your dimensions before you perform addition or subtraction, because if the dimensions are not identical to the other matrix, you cannot perform addition or subtraction. I trust A plus B will be pretty smooth for you. Perhaps where you may be a little scared is a fraction. 1/2 plus 3/2. Since you have a common denominator, we just add the numerators. 4 divided by 2 is 2 over 1, which simplifies to 2, which is how we got this term right here, this element right here. The rest I trust you can take care of. And then I can trust you can do B plus A. Remember, this means that the B matrix comes first and then the A matrix comes second. So adding these two matrices, you will get this result right here. Make sure to take some time to try it out for yourself to verify this is the case. So for A minus B, we get this result right here. Recall that in performing this operation, we're going to start off with matrix A first, the way it's supposed to be. And then B comes afterwards, so you would go ahead and switch all the signs of matrix B, all the elements in matrix B, and you would go ahead and perform the addition that goes with that, right? Because we're essentially performing A plus negative B. So we don't have to worry about the signs. A particular note that some of you may need assistance with is the addition of this element in A with this one in B. So we have 1/2 plus a negative 3/2 is a negative 2 over 2, which is a negative 1, hence the negative 1 term. For B minus A, I'm going to go ahead and show you this one all the way. I'm going to rewrite matrix B. And this will be our first matrix. Then I'll do an addition. And then I'm going to go ahead and do matrix A, but I'm going to switch all of the signs in matrix A. So this is the setup that I'm working with. I can then go ahead and pair off the elements just by adding. I have this 3/2 and this minus 1/2. That is going to give me a 2/2, which is going to be a 1. Negative 3, negative 5, positive 4, positive 2, 0, negative 5, and 2. And this is going to be B minus A. Please note how this answer compares to what we just did previously with A minus B for this problem. For your summary, in general, and you may wish to refer to problem 3 part G that we just did, is A plus B equal to B plus A? Or is A minus B equal to B minus A? Take some time to reflect and to explain. Maybe even consider some examples where it might be true, right? We call these counterexamples in geometry. So take some time.